Welcome back. Let's now move on to the concept of symmetry. We're going to look at one scenario for each of sine, cosine, and tangent relating to inverse trigonometric functions. When we're going from a coordinate to identify an angle measure, then we're working with inverse functions. So let's consider the scenario of the inverse sine function of sine value of 0.5 and the inverse cosine for a value of 0.5 and inverse tangent for a value of 1. And in each case I'll create a unit circle, and I want to identify where I have angles in one 360-degree revolution that have these values for sine, cosine, and tangent. Now the angle, if I know the main angles in the unit circle, I will be able to identify the angle which has a cosine value of 0.5 as 60 degrees. I'll be able to identify the sine value of 0.5 with the angle 30 degrees, and tangent of 1 is with an angle of 45 degrees. Now, in understanding symmetry, we want to think about what is the sine coordinate. The sine coordinate is the y value. So when I say that the sine of 30 degrees is 0.5, or in this case more specifically, knowing that the sine value is 0.5, an angle, not the angle, but an angle with that sine value is 30 degrees, it's because of the y coordinate. Now the y-coordinate, if I look at where this point is in relation to the y-axis, I notice that if I work my way over to the left, there's another point on the circle that has the same y-coordinate. And therefore, I have two coordinates on the unit circle that have a sine value of 0.5. The other one in this case is 150 degrees. And there's a symmetry concept that's happening there. Let's look at the symmetry angles in relating to cosine and tangent, and then we'll look at formulas we can use to calculate or identify two angles with the same trigonometric value in the unit circle. Cosine has a value of 0.5 at the angle 60 degrees. Cosine is the x-coordinate, which means that on the x-axis I have a particular cosine value, and notice that I can go down to the other side of the unit circle and I will have another point with the same x or cosine value. That angle is 300 degrees. And for tangent, as we've already seen with our periodicity concept, I know that exactly 180 degrees from my starting angle, which will be 225 degrees, I have the same tangent value as I do at 45 degrees. So these three observations all relate to the concept of symmetry. Now, these are only three examples of a variety of symmetry identities in trigonometry, but these three will be valuable to us in working with scenarios in which we know a sine, cosine, or tangent value, and we want to identify all of the angles in one 360-degree rotation, or more than one 360-degree rotation for that matter, which share a common trigonometric value. So the symmetry formulas that I want to use here for these observations are the sine of 180 degrees minus the angle is the same as sine of the angle. For cosine, cosine of 360 degrees minus the angle is the same as cosine of the angle. And for tangent, tangent of 180 degrees plus the angle is the same as tangent of angle. And the way you determine which of the angles you want is based on a restriction given in your problem. Let's look at the calculator output first, and then we'll talk about the restriction and how that helps you to identify the correct angle. The calculator value for inverse sine of 0.5 is 30 degrees. Now we know that's not the only possible angle. That's one. The calculator value for inverse cosine of 0.5 is 60 degrees. And the calculator value for inverse tangent of 1 is 45 degrees. And you need to use the symmetry equations that we see here, the symmetry identities that we see here, to determine what the actual angle is that you want to calculate. So to make the decision, I need to know the interval that I'm working with. And my intervals could be 0 to 360 degrees, 0 to 720 degrees, 0 to 180 degrees, 180 to 360 degrees, etc. Let's say that in the sine example, I'm given an interval of 90 degrees to 180 degrees. Well, I can see that in my two examples, or my two angles, 30 degrees and 150 degrees, only one of my two options, 30 degrees and 150 degrees, only one is in the interval 90 to 180. So that's how you identify which of the two angles you're looking for. In the case of cosine, let's say that the interval given is 180 degrees to 360 degrees. In this case, considering my two angles of 60 degrees and 300 degrees, the only one that's in that interval is 300 degrees. And in the case of tangent, let's consider the interval 0 degrees to 180 degrees. And of my two options, 45 degrees and 225 degrees. I see that only one of these is in the identified interval, and that is 45 degrees. And so using the interval guidelines, I can identify which angle or angles that I've identified as possibilities qualify. In the case of the sine example, the interval 90 to 180 allows for only one of 30 and 150 degrees. If the interval had been 0 to 360 degrees, then I would include both 30 degrees and 150 degrees. The interval could be 0 to 720 degrees. And then along with 30 and 150, I would add in 390 and 510. So note that what the calculator gives you is the first angle that has the inverse value. It's then up to you to decide which angle or angles meet the particular scenario you're working with. Note that these three examples are all positive inverse function values. Let's look at examples of negative inverse function values coming up in the next video.